Hey everyone, welcome back to the channel. If you are new here, my name is Firas, and today we are diving into one of the most important topics in the world of databases, SQL and NoSQL. So, without further ado, let's jump right in. So, let's start with SQL. SQL stands for Structured Query Language and is the standard language used to interact with relational databases. But what exactly does that mean? Well, SQL databases use a structured tabular format to store data, and data is organized into rows and columns within tables. Data is often normalized, meaning it's divided into related tables to minimize redundancy. This ensures data integrity, but can lead to complex queries to retrieve related data across multiple tables. However, SQL is a powerful and expressive language that allows for complex queries involving aggregations and joins. This makes SQL databases ideal for applications that require complex data relationships and precise queries. Before data is inserted, the schema or the structure of the tables must be defined, and every record must adhere to this schema. So each table has columns, which define the type of data, and rows, which store the actual data. Like this table, that represents a user's table in a SQL database. We have those columns starting with user ID, which is the primary key of this table. In general, in SQL databases, each table should have a primary key. A primary key is a column or a combination of columns that uniquely identifies each row in a table. This ensures that every record in the table can be uniquely referenced. And we have other columns representing different attributes in the table, such as the name, age, and email of a user. In SQL, each column in a table has a data type that dictates the kind of data it can accept. For instance, we can see here the user ID column is only allowed to be an integer. Similarly, the name column is only allowed to be a variable character or a string, and so on. In SQL, we also have constraints that go beyond just defining data types. So constraints are rules that enforce data integrity and restrict what data can be entered into the table. They enforce rules like making sure a column is never empty with not null, or that each email in the users table is unique using the unique constraint. So this can be implemented in SQL like following when creating the table. So we have constraints for each column, and we can insert valid data using the following SQL query with a valid name, age, and email. Now if we try to insert an invalid age, like a negative number, the database will reject the data. Or if we try to insert an email that already exists, then the command will also fail. So this ensures that only valid and acceptable data gets stored, maintaining the integrity of your database. One of the biggest strengths of SQL databases is their ability to handle complex queries and relationships between different pieces of data. For example, you can easily join data from different tables, ensuring that everything stays connected and consistent. This is why SQL databases are often referred to as relational databases. For example, we have two tables, orders and users, and we want to join data from both tables. We can see that the orders table has a foreign key. This will reference the user ID in the user table, establishing a relationship between the two tables. This allows you to track which user placed each order. Now, if we want to fetch all orders along with the user details, we could run a SQL query like this. This query will return a list of all orders with the corresponding user's name and email. So the result will display the name and email from the users table along with the order date and amount from the orders table. The join matches each user ID in the users table to the corresponding user ID in the orders table. For scaling, SQL databases traditionally rely on vertical scaling, or scaling up, by increasing the resources of a single server. For example, adding more RAM, CPU, or storage. This approach has limits and can become expensive. Horizontal scaling is also possible in SQL databases, but it's more challenging due to the strong consistency and complex relationships between data. This often requires partitioning data across multiple servers, which can introduce additional complexity. Popular SQL databases include MySQL, PostgreSQL, Oracle, and Microsoft SQL Server. These databases are great for scenarios where data integrity, multi-row transactions, and structured data are critical. Now let's understand what NoSQL means. The term NoSQL stands for not only SQL. It's designed to handle a wide variety of data types and workloads that traditional SQL databases might struggle with. Unlike SQL databases, which follow a structured, table-based format, NoSQL databases are schemaless, meaning they don't require a fixed structure or predefined schema for the data. Instead, NoSQL databases can use a variety of data structures, including key-value pairs, column-oriented, graph, and document-oriented. This flexibility allows NoSQL databases to handle unstructured or semi-structured data, making them ideal for modern applications like social media, big data, and real-time analytics. And when it comes to access, NoSQL databases often use simplified queries tailored to their data model. For example, a document database might use JSON-like syntax. Imagine you are storing user profiles in a document database, then each user's data is stored as a JSON document. If you want to query this data, you use a query language that resembles JSON. For instance, to find all users whose name is Alice, you would write a query like this. This query searches for all documents in the user's collection, similar to a table, where the name field is equal to Alice. Another example in a key-value store, it stores data as key-value pairs, where the key is a unique identifier and the value is the data associated with that key. This type relies on simple set and get operations. For example, imagine you want to store user sessions in a key-value store. The key could be the session ID and the value could be the session data. Now, if you want to retrieve the session data, you simply use the get operation with that key. So this trade-off allows for faster performance and higher availability, but it may not support complex queries as easily as SQL databases. In terms of scaling, NoSQL databases excel at horizontal scaling. They are designed to distribute data across multiple servers or nodes, making it easy to add more servers as your data grows. This makes them perfect for handling massive amounts of data and traffic, especially in modern applications like e-commerce, IoT, and real-time analytics. Let's take a look at some of the most popular NoSQL databases out there. MongoDB, which is one of the most popular document databases. It stores data in flexible, JSON-like documents. It's widely used in web applications, content management, and big data systems. Apache Cassandra is a distributed, wide-column store known for its high availability and scalability. It's used by companies like Netflix and Twitter. Redis is an in-memory key-value store, often used for caching, session management, and real-time analytics. It's known for its lightning-fast performance, making it a top choice for applications that require quick data access. Amazon DynamoDB is a fully managed key-value and document database that offers seamless scalability. It's a popular choice for applications with unpredictable workloads such as gaming, IoT, and real-time bidding systems. Neo4j is a graph database that focuses on relationships between data. It's perfect for use cases like social networks, recommendation engines, and fraud detection, where understanding connections between data points is crucial. In summary, the choice between SQL and NoSQL depends on your specific use case, the nature of your data, and the requirements of your application. So use SQL when your data is structured or you require complex queries and reporting. Or use NoSQL when your data is unstructured, you need to scale horizontally, or you require flexibility and performance for real-time or big data applications. Okay, that's it. Thanks for watching.